Hi all, in today's video we will try to understand one of the basic operations in computer vision for image processing, that is morphological operations. So, morphological operations, it's quite been a popular technique that is being used in image processing for traditional computer visions, and it can be used for different types of use cases like shape analysis, feature extractions kind of stuffs, and it can be used in other use cases as well, and we will try to discuss all of those use cases one by one in this video. And alongside with that, we will try to understand what are the different types of morphological operations in computer visions and what are the use cases of it. After that, one of the use cases or one of the types of the morphological operations, dilations, that we will try to understand in great details in this video with a practical example and implementations alongside of that in this later part. But before we start into that things, first we have to understand or motivate ourselves what is the use cases, why we should learn the morphological operations for image processing. The first thing is that it can be used, that is noise reductions. It can be used in different types of noise reductions that can be present in an image. It can be used for object detections and segmentations as well, but our main focus will be in noise reductions. Okay. And there are two types of morphological operations. One is the dilations and its complementary, that is erosions of the image. But erosions and other stuffs we will discuss in a great details in other videos. Our main focus in this video will be the dilations. So, dilation is basically, if you look into the Wikipedia, it has some basic definitions. It is saying that it is a mathematical morphological operations and it is being used for binary images, that is my grayscale images, but it can be used for lattice, complete lattice, that is our 3-channel color images as well. And if you look at these mathematical operations, you will see that there are two things. There is A, that is my input image, and B, that is my structuring element. So, what is structuring element? And the structuring element is basically a window, and that will be operating on my input image A, and after operating on input image, it will give me A underscore B. So, A underscore B is my translation of A by B. What does it mean by that? We will try to understand by an example. Let us say you have a window, you have a structuring element, and that is being shown here by this green window. This is my structuring element, and the center of the structuring element is this red point. Now, if you have a input image of this upper image is my input image, and the center of the input, center of the structuring element is coinciding each one of the pixels in the input image, and that input image of the actual the center, the pixel value of the input image, that is coinciding with the center of the structuring element. We call it as a structuring element. Sorry, that is we call it an input pixels. So, the pixel value that is coinciding with the center of the structuring element, we call it as a input pixels. Now, if any of the pixels covered by our window is matched with the input pixel value, then our input pixel value will be covered, will be replaced by that value. Okay. So, but basically what is happening is that you are placing your window on any of the pixel values of your input image, and that pixel value that is coinciding with my center of the structuring element, we call it as an input pixel. And now, if any of the pixels covered by our structuring element is matched with the input pixel values, then our input pixel values is replaced by the matched value. Okay. And if you continue sliding your structuring element through over the input image, you will get the output of something like this in the lower image that I am showing. Now, if you look it carefully, you will see that in the upper image, that is my input image, there is so much noise around this structure, right. So, in the image, if you look at the image, there are too much of noise in this image, but if you look at the output image, you will see that there is a drastical reductions in the noise in the output image. So, what I want to establish is that dilation is very much useful technique in case of noise reductions in the image and image smoothening in this case. Okay, and another thing just I want to pinpoint is that here we are using the kernel type that is called flat kernel. Apart from flat kernel, there are different types of kernels that you can use, but that is beyond of the scope of this video. If you are interested into that, you can search it on Google and you will find some good resources on different types of kernels that can be used for these use cases. But in this use cases, whatever I have used for this video or this image, this is being used by a flat kernel. Okay. Now we will jump into the implementations of the dilation functions. For that, we are using OpenCV's dilate inbuilt functions. First of all, I am just importing the OpenCV library called CV2, import CV2, and then I am reading my input image and storing it here. Then I am declaring the kernel. Here I am declaring the kernel as 3x3 with all the values of 1s. Okay. Now, by exploiting the OpenCV's dilate functions is taking this input image and the kernel and the iterations. Iterations is basically what number of times you want to iterate over the input image over the times, and this is basically a single iterations output of the image. If you want to apply it for the several times, you can apply it again and again, but for this case I am using the iterations number of 5. Now I want to show you the output of it. I have taken a noise image as my input, and the output should looks like a smoothed non-noisy image. If you look at it, you will see that this is my input image and this is my output image. And if you look at carefully, my input image is so much of noise, but output image is having a drastically less number of noises and it's being smoothed out. And this is one of the use cases for dilations in case of image processing. Thank you.